and I am with the Dickinson District. Over the years, I've come to appreciate that there's always something new to learn or a detail I may have previously overlooked. Some of you may share a similar experience. When I was given the opportunity to prepare this presentation for our districts, I chose to focus on the basics of guardrail inspection. While this is a broad subject, my aim is to cover the inspection basics that will serve as a refresher. I recognize that I won't be able to cover every detail today, but I hope this session provides some valuable insights and reinforces the basics of guardrail inspection. Before I begin, I would like to take a moment to address an important safety topic. Many of you are likely familiar with situations where someone experiences a medical emergency, such as chest pains, and is administered aspirin before medical professionals arrive. What if aspirin was not available, especially in environments like a construction site, remote construction sites? This is a scenario we all hope to avoid. It's hard to carry any medications around, but a practical solution I found is to use an emergency pill fob attached to a keychain so that vital medication is always within reach. This is my key set of keys here, and this is the pill fob. I personally have one, like I just showed in this picture, and I encourage everyone to get one. If you have one but haven't checked your medication in it for a while, maybe now is a good time kind of to do so and make sure that the medication in there, not expired or anything like that. Okay, here's the agenda for the training. Today, I plan on covering plant requirements. I'll go over standard specifications like removal and installation requirements. I'll go over standard drawings, common issues I've seen in previous projects during inspections. I'll go over final inspection and acceptance of a guardrail system. And at the end of the training, I'll take your questions. Okay, common guardrail types you'll see on DOT projects. We all seen all these out there. You'll see W-beam guardrail like I show in the top right picture there. Box beam guardrail like this over here. These are really common on bridges. And cable guardrail like this over here that the DOT has been installing a lot, lately on interstate medians. I will not discuss inspection of all these types of cable guardrail today. I'll focus on inspection of W-beam guardrail with a fleet end terminal. This is the type that we installed on my project last year and then, the year before. On this project, we also installed a short run of the high tension cable guardrail, which is what I show in this picture here. Regardless, the same principles of inspection that I'll go over today can be applied really to all types of guardrail systems you might be working on. Okay, before you begin your guardrail inspection work, obviously you want to review the project plans. This is always a good starting point. In there, you can ask questions like, is it a remove and reset guardrail? Is it new guardrail that you'll work on? What type of roadway are you working on? And is it open to public traffic? So where in the plans would you find guardrail information? Well, for most projects, this will be found in Section 130 sheets, and this is part of the Section 130 sheets that I show here. In the first page of this sheet, you'll typically see a layout like this, and the layout just kind of tells you a lot of information about offsets, how long the guardrail is, Is it protecting a bridge structure, or is it just protecting like a steep inslope? However, this is not the only section that covers guardrail that you should review. Depending on the project, guardrail installation work may also be covered in Section 6 notes, Section 20 details, Section 100 details, and of course in the standard drawings. Here is also a part of Section 130 that you'll see in most plans. This sheet shows material details of posts, blocks, and hardware that's required for the guardrail system. In this section, you can see if you are installing new guardrail, like for example over here it shows material quantity for new guardrail. If you're resetting some, like you'll see, like this over here, you're resetting some guardrail system, or all of the existing. Now, on this project over here, we did not really reset any guardrail, but I just I pulled this over here from a previous plan just kind of to explain this. What should you do before you remove guardrail system? Really, in most cases, you have guardrail systems to remove if you're updating it. First, if you are resetting guardrail on your project, I would recommend that you check the condition of the existing guardrail while in place. Make sure that the guardrail is good to reset. If they are not, work with the contractor as soon as possible to get new pieces. And of course, this may require a change order or increase to bid item. I think checking the condition of guardrail during the PS&E stage is one way to avoid having to change order guardrail pieces meant to be reset on projects. I encourage districts to kind of work with designers early. Not that it's not happening, but sometimes designers might probably estimate or something like that, what guardrail would need to be reset. Excuse me. Okay, the second thing to do is to get a guardrail schedule. This is covered in Section 764 of the spec book. The contractor is required to develop a written construction schedule for work at the guardrail location. Make sure you get this schedule before the guardrail removal really takes place. The schedule can be in any format like I show here. Like for this one, for example, when we requested a schedule, it could just be a simple email like this, covering what the item is, the activity duration. Review the schedule, make sure that the sequence makes sense. Lapses between each controlling item is less than or equal to 4 working days. Again, that's in Section 764. Controlling items, like I said, would be items that must be done before the guardrail can be installed, which is, obviously before you install the guardrail, you got to remove it. You got to remove all of the asphalt. You got to do base work, and then obviously install the guardrail. So I just want to emphasize that you do not want more than 4 working days to elapse between these activities. Okay, before you remove guardrail as well, the third thing you want to do is to make sure that the hazard is no longer present. This is also covered in Section 764. The hazard could be a steep slope area, like this over here. This is a steep slope area that's being protected by the guardrail. It could also be a bridge pier, a box culvert area that will need to be extended on the project, and so on. In such cases, make sure the hazard is addressed and is no longer present before you approve guardrail removal. In some cases, if the roadway is going to be open to public traffic and you must remove the guardrail in order to work on the area, your project plans might show traffic control items that are needed to be put in place before that happens. Okay, after meeting the plan requirements and specification, you're almost good to approve guardrail removal. Like I say, if the roadway is going to be open to public traffic, make sure that you have all the traffic control items on site. There have been instances where, I'm pretty sure some of you have had that, where really the traffic control items are not all on site, and the contractor removes the guardrail and only to find out that you don't have the required traffic control items. So section 764 says to install delineated drums at 25-foot intervals. You want to make sure that that's installed, and then the drums really cover the length of the guardrail that was in place. So start installing all of the delineated drums if you're protecting a bridge structure from the blunt end, and then run it along the length of where the existing guardrail was in place. Well, the guardrail has been removed. Where is it going? So in some plans, the section may be found in section 6 plan notes. Make sure you review that. Like I have here, this is a section. This is in the plan note, section 764 plan note. You are either going to reset the guardrail. So in this case over here, part of the guardrail system was delivered to DOT facility, and then the rest of it became really the property of the contractor. So just make sure that you look at that. If you're going to deliver part of it to the DOT, make sure that the right pieces noted in the plan notes are delivered. Like this over here, you can kind of see that it called for just the impact heads, the struts, the steel posts, and then the trailing anchor. Work with your section supervisors, give them a heads up. You know, some of them kind of might have requirements of where to stockpile them and things like that. If your project has guardrail reset, I also recommend you review the Highway Barrier Pocket Book. You may have seen this book. If you don't have one, there's a copy, a digital copy that you can find on the DOT website under training and certifications. I actually have this book, and I wasn't really aware that there's a lot of information there as far as resetting guardrail. While researching for this presentation, that's when I found that. This guide shows guardrail deficiencies that will help you identify acceptable or unacceptable guardrail pieces. I'll discuss some of those deficiencies in the next few slides here. Okay, I talked about checking the condition of existing guardrail well ahead of time. From the pocket guide that I showed in the previous slide, these are examples of unacceptable guardrails that you do not want to reset on your project. You'll see, if you see pieces with rail deflection like this over here, this is deflected out, or rail flattening, you can kind of see, I don't have a picture of rail flattening guardrail piece, but you can kind of see that this is also flattened over here. So a piece like that you do not want to reset. Pieces with non-manufactured holes, like this over here. Pieces with rail splice damage. This is a picture kind of showing a rail splice damage right there. Or rail tears, like this. Do not reset guardrail with these deficiencies. Okay, again, for a project that's open to public, you want to install the guardrail as soon as possible. This is covered in section 764 of the specifications. So you want to make sure that you get that as soon as possible, and that's why you require the contractor to submit a schedule that we talked about in the previous slides. The section 764 requires installation of each individual run within 10 working days from the date all controlling items allow guardrail installations to begin. This is pretty important. Make sure you enforce that. If you're working on a roadway that's not going to be open to public traffic, then this part of the specification really does not apply to that. If the contractor does not comply with this specification, make sure that you enforce it by making a $1,000 a day deduction, if not corrected within 24 hours. But have those conversations well ahead of time so the contractor is well aware of this, and the need for a contract deduction would not be necessary. Okay, with the guardrail now removed, what is the next thing you want to do? You want to stake the pad. Typically, I'll have a contractor submit a staking request. For staking the guardrail widening layout, start with section 130 like we talked about earlier. Stake or mark the points that I show in blue dots. A lot of times those will be staked. This will ensure that you really have the layouts that's called for in the plans. These points are important for determining the lengths and offsets of the guardrail pad. Note that there's, make sure that there's 2 feet behind the guardrail. Like over here, you want to make sure that your pad extends 2 feet behind the guardrail. Like right there, this over here is 5 feet. So kind of properly staking this will ensure that you build the pads according to what the plan shows. On this project, we had the in-slope really met plan requirements, but for some projects with steep slope, you may have to slope stake your in-slopes over here to ensure that you get the correct in-slope rate. Okay, after laying out your offset, stake elevations. Like I talked about, section 20 may have details you want to look at before you stake grades. If you don't have this detail, you could survey existing center line to carry out the elevations to the desired points, or get it, work with your designer on that. So this really varies from project to project. On my project, I had this detail here, the section 20 detail that shows, your layout there. And as you can see, the cross slopes really vary from center line to the shoulder and then to the guardrail pad. You can also see what kind of thickness you want to have. Over here at the guardrail location, it shows a 2-inch thickness, and it varies away from the guardrail. For this training, let's say you start with an elevation of 2,000 at center line, and this is really my starting reference. And from that, if you do not have all of your elevations, you can calculate the elevation to any point along the guardrail path that you want. Note the varying cross slopes. Obviously from the main line, 2.1% to the shoulder, 2.9%, to the guardrail pad, 5%. Some plans might show this as 10%. On this project, it was 5%. So make sure that you have the correct slope to your guardrail pad. From this, you can also calculate any elevations that you would want to the base grade or to dirt grade. Here's a close detail. Again, note that 2 feet is required behind the guardrail and asphalt thickness must be 2 inches. I just want to restate that properly installing the guardrail starts by properly staking the guardrail widenings and making sure that it's constructed to the correct layout and grade shown in the plans. Okay, with staking now complete, the next thing is paving. Follow your section 430 requirements for paving. Check your depth to make sure that the 2 inches is paved. Double check your slopes. You should be around 5% or 10% depending on what your plan calls for at this point. Like we discussed earlier, paving the widening is basically one of the loss controlling item, like from the schedule. So make sure that the contractor knows this and calls and locates, hopefully that same day, to get the ball rolling towards installing the guardrail, especially if you're working on a roadway that's open to public traffic. This picture over here is not from my project, but I got it from another district. Okay, another reminder that I want to say is not all projects will require barrier modification, but for projects that do, pay attention to the modification details. The drawing that I show here, part of the barrier modification detail from my plans. It's really in section 170 sheets. So one thing I want to point out is that the contractor typically would bring in prefabricated plates. Make sure that the plate dimensions are correct, so that the 1 foot 6 inch dimension I circled here is correctly installed. If the plate is at the wrong location, then the post spacing in the thrive beam area is going to be affected and will be off. So I'll show a slide here coming up. So you want to make sure that this 1 foot 6 inch over here is pretty much correct. Otherwise, it'll affect your post spacing as you start laying out the guardrail. So check your dimensions. Make sure that's all good. I've had this issue before where the plates was at the wrong place and the contractor comes in to install the guardrail, and we had issues and we had to do some removals to kind of get that set right. So you don't want to do that. Well, with the pad is now paved. Just mark your post locations. Most contractors will want a starting reference point like this over here that we staked out. This is especially if they're working on a guardrail that's not protecting a structure. So they'll want a reference point, and then from that they will lay out the guardrail posts. If the guardrail is protecting a bridge end, like this one over here, then the contractor will normally lay out the post starting from the bridge end. In this case, excuse me, make sure that the offsets and post spacing shown in section 130 are correct. Have your surveyors verify this, for your offset, and make sure that it meets that section 130 layout sheets that we talked about. Okay, before you install the posts, check the lengths. The plans will specify the types of posts required in section 130, like we talked about there. You're either going to have 6 foot or 7 foot posts depending on where they are located on the guardrail run. You can see here, there's a 7-foot post and a 6-foot post there. For MGS type guardrail system, the posts are driven to 32 inches above ground. Section 764 requires the post to be plumb, with the front faces uniformly aligned. Contractors typically run a chalk line for this reason. Install guardrail to produce a smooth continuous line with uniform height. These are some of the requirements that are in section 764. As you review this and as you inspect this in the field, make sure that this is what's being installed. Once the posts are installed, backfill them with 2 inches of approved material, and this is typically cold mix. The posts are required to be wood posts, except for the last 2 posts. So all these are wood posts all the way from here to the bridge end, except for those last 2 posts, those are steel. This is a requirement in the standard drawings. Okay, installing the Tri-Beam, the contractor will typically start installing the system from the bridge end. We'll start from the bridge end. As we discussed, make sure that with the barrier modification, as we discussed in the previous slide with barrier modification, if this was done correctly, you should have no issues attaching the guardrail, and your first post should be at the correct distance. So this is what I talked about in that previous slide. I talked about a 1 foot 6 inches. You can kind of see here that the distance to the first post is 11.5 inches. So if this is offset at the wrong location, then that's going to affect the first spacing here. So for this project, the plan shows to install the Tri-Beam per standard drawing 764. This is part of that 764 standard drawings there. Okay, again on installing rail, 64 standard drawing 6438 shows that your height needs to be 31 inches for guardrail. Like I talked about before, those are wood posts except for the last 2 terminals. The tolerance is 1 inch on guardrail heights. So other guardrail systems may have different height requirements, so just be aware of that. I talked about in the previous slide that the posts are driven to 32 inches and then the guardrail is at 31 inches above ground. That difference of 1 inch is right here, or right there. Once the posts are installed, contractor will install the rail. Rail panels are typically 12.5 feet or 25 feet long. With that, many pieces will be spliced together to make the required run. Pay attention to the splice details and the tolerances as you inspect the guardrail system. For example, there should not be a center bolt in the slot in the midspan. So this is the splice detail over here. You do not want to have a center bolt installed right here. This should be just like the way I show in this picture. Just a reminder that one of the requirements in section 764, like we talked about, is to make sure that there's a continuous smooth line with uniform height on the guardrail. So you do not want to have, you know, an up and down variation in height. Okay, more on installing rail. Lap the guardrail in the direction of travel on the adjacent lane. This is to reduce the chance of snagging. So make sure that the splices are in the direction of travel, like this here. So you do not want to have that offset the other way. In the highway barrier pocket book, it talks about even if the chances of that is low, that there's been kind of incidences with maintenance equipment, you know, catching onto it. Okay, installing terminal, just talk about the standard drawing 76438 there. Like I talked about, the last two posts are steel. All of the rest are wood posts. At post 2 and 3, the open-ended slot at the post bolts are on the upstream side of the post. I'll show this better in the coming slides here. Also, another thing to note is the soil plate on the downstream side. This is where the soil plate needs to be installed. You do not want to attach that rail to the third post over here. Okay, more on installing additional rail. Make sure that there are no loose cable anchor, like this over here. This is supposed to be taut. Make sure that the bearing plate retainer ties are installed. That'll be here. I'll show a picture of that better a little bit. The stubs at posts 1 and 3 have to be 4 inches max over here above the ground line. So ensuring all of this is according to the standard drawings will ensure that the system works like they're supposed to. I pulled this drawing from one of the MASH fleet guardrail checklist in the DOT manual there to better show the different components of the guardrail system. In one of the slides previously, I talked about the open slots facing post 1, which is this one over here. Make sure that this is facing this way or facing the direction of oncoming traffic. Okay, and also in here you can kind of see that the bearing plate, this bearing plate over here should have a retainer like I talked about in the previous slide. So I found this drawing here kind of pretty good to kind of show some of the terminologies and you know, guardrail height and different things like that. So. With the end terminal installed, one of the last things the contractor will install is the reflectors. The standard drawing requires the contractor to begin installation at the first post and then space them at 25-foot centers on guardrail less than 250 feet length, and at 50-foot centers for guardrail over 250 feet. So reflector color should match the pavement marking adjacent to it. The reflectors are installed on offset blocks, not the posts. So this is where they should be installed, like you can kind of see over there. is installed on the blocks. Okay, I now want to go over some of the common issues we have identified during inspections on past projects. This is not all from one project, but this is just a collection of pictures from projects that we've done over the last few years here. Like you can see over here, the left picture shows the guardrail not really attached to the block and the post behind it. So you can kind of see it. This should have been lined up over here. The post really is at the wrong spot. So that's kind of what ended up happening, that the contractor came back and corrected, reinstalled the post at the right location. This picture over here, you can kind of see that the bolt is really not tight, and the retainer is really not really behind this and really attaching to that properly. So the retainer plate was pretty loose. This picture over here completely missed a bolt. So these are some common issues that you'll see. Make sure that during inspections you kind of work with the contractor and make sure that those are addressed as they're installing the guardrail system. Additional issues that we noted during inspections, leaning post in the left picture here. You can kind of see that this post is leaning. Those two posts are leaning towards each other. Post is supposed to be plumb, like we talked about for the specification. This picture over here is showing missing nuts. This is really, this angle plate is not really attached to that. This picture to the right over here is also missing. I'm not sure what happened here, but I think it's missing bolts to this last post over here, and the terminal is completely detached. Okay. Also, there's extra holes here. This hole was completely missed. You can also see that there's a little bit of rotation in this block here, in this post here, and also the post damage. I'm not sure what is going on in this picture over here. I got this from somebody else, but it seems to me like it's an extra non-manufactured hole in here. The right picture shows a partially filled cold mix around the posts. So make sure that this is filled in properly and compacted. Otherwise, you're going to find things like this, or some settlement in it. Last slide on common issues. This left picture over here shows block rotation. I probably didn't mention that, but the posts and the blocks are supposed to be toe-nailed to the post to avoid this. But this is from one project that I had. It was not because it wasn't toe-nailed, but there was a little contact with this, a wide load or something came through and made this happen. I didn't have a picture on this one over here. The cable anchor is supposed to be taut, so you'll see that it should be in a straight line, kind of like this, and not sagging like that. So this picture came from the pocketbook guide that I talked about earlier. While your guardrail installation is now complete, what would you do next? Obviously inspect the system. You've been inspecting it, throughout the installation, but you want to do a final inspection. I found some guardrail inspection checklists in the website. I had no idea some of them were there, but the checklist really summarizes important items that you should not miss for the guardrail system that you're working on. I think this is something that I will have all the time to go out and inspect the guardrail system and document it. So just if you go into the training, into the DOT website, make sure that you get a checklist that is for the system that you are actually installing. I think I got this over here from the from design, so folks at design. Another thing that I like to do is invite our maintenance guardrail installer to, once we finish up all our inspections, invite them to review the guardrail system with us. Since they take over really the project in the end, and they actually active in installing guardrail system, and they can kind of point out to any issues that we have in the field. So it's one thing that I encourage you to do, and kind of just get with your guardrail installer in your district to kind of check the system and make sure that when it's passed on to them, it's all inspected correctly. Okay, just some of the key points that I like you guys to take away from this training today is we covered a lot, but if you are going to reset guardrail, check its condition as soon as possible. This will ensure that when you are out there and the contractor is ready to install guardrail, if it's going to be reset, it's in good condition. If it's not in good condition, you can get additional guardrail ordered in. Make sure you get a schedule for guardrail on roadways open to public traffic. Hold the contractor to that. Make sure that they follow the schedule, and ensure that the guardrail is really installed timely. If you're going to have a barrier modification on your project, make sure that you check all your dimensions. Make sure that it meets what the plan and standard drawings show. This will kind of really avoid having issues when the guardrail installer gets to site, and only to find that there are issues and it delays the guardrail installation. Get a checklist like I kind of show here in the last slide. Get a checklist to inspect the guardrail system. Follow that, work with the contractor, make sure that the issues are addressed. Once the issues are addressed, invite your maintenance guardrail installer in your district, if possible, to get with you and take one last look at it before you accept the system. With that, I'll take your questions. Josh, can you see any questions on the chat?
Nope, I don't see anything at this time.
All right, if you have any questions or anything like that, you can reach me at my telephone number there or email. Thank you.
Thanks, Dennis. Next, we have John Young with ND Safety Council. He's going to discuss trench safety. Not sure if he's on yet. We might have to wait a little bit. Yeah, while we're waiting, we can take a 10 to 13-minute break. Wait for John to get on.
I'm not hearing anything.
Hey, John. Hey, John, I see you're on. We're just on a break here waiting for you to get on, so.
Oh, good. I thought maybe I was about to text you because I thought maybe somehow I was being blocked with all the people on. So,
No. We'll get started here in a minute when everybody comes back.
okay, that sounds good. Thank you.
Thank you. All right, it's 10 o'clock. We got John Young with the ND Safety Council going to discuss trench safety.
All right. First off, Josh, can you hear me?
Yep.
All right. Um, Now, would you like me to just discuss it? I do have a kind of a PowerPoint I might try to share, but I don't guarantee that it's going to show up. You want to give me, I'll try to do that right now. Hang on
Okay.
here. See what happens. And then Josh, just to make sure the group that we're talking, hey, can you guys see it?
Yes, sir.
Awesome. Fantastic. All right. So the group that we're talking to are mostly field people, engineers, technicians, combination everything.
Correct.
Oh, perfect. All right. So everybody, I'm going to go over this from basic understanding. Now, you guys aren't digging your own holes, I take it. You're probably contracting, correct?
Right.
All right. So before I begin, I'm going to refer back to my OSHA experience. Everybody, my name's John Young. I spent 8 years as corporate safety director. I spent 20 years in OSHA, 17 years as a field investigator, and 3 years as the assistant area director. And then when I retired from OSHA, I went to work for the National Safety Council in North Dakota Safety Council up here. And I kind of helped teach trench training. So a couple of things right off the bat. No one can absolve themselves from their responsibility for safety by contract. That's the bottom line up front. And what I mean by that is whether or not OSHA may have jurisdictional authority to issue a citation, from a legal liability standpoint, if you see it, know it, and don't do anything, you guys are on the hook. Particularly if you're an engineer in the civil area or a technician in the civil area, there is a higher expectation of knowledge, right or wrong. All right. So what I'm going to do is cover some of the basic concepts of trenching and trench protective systems. Now, this presentation is designed as an entry level, but I'm going to talk differently, knowing who all y'all are. So again, let's see here. You know, trenching every year kills hundreds of people. And the funny thing is, you know, a lot of these contractors out there get used to it. And they don't realize there's certain things that the way OSHA looks at it and the way industry, you know, looks at it from a legal standpoint, which makes trenching probably the easiest to understand. I mean, we all know that the Earth moves 67,000 miles an hour around the sun, right? That's all and butt. We know it spins on its axis at 1,000 miles an hour at the equator. We know those two competing forces create our gravitational situation that we're in. And that same gravitational situation, you've all seen it. The Earth is compressing itself. It's pushing down. So any excavation or cut, and the definition of an excavation, all right, is any divot in the Earth fills in. You've all seen it. You dig a hole, you come back the next day, it starts filling in. Depending on the mechanics of the soil, it'll fill in quicker. You've all been to a beach. Dug a hole in the sand and watch it immediately start to fill in. So when OSHA looks at this, they're looking at it from the standpoint, you know, along with ANSI, because OSHA's standard and ANSI standards are almost identical, of protecting the employees in a trench and in an excavation. And they're looking at it from the standpoint of the mechanics are always the same. Trenches, you know, the soil's going to push down and in to fill the void. And we'll talk here a little bit about voids before I get too far in. As many of you are aware, voids are those gaps between those submicron particles of, you know, granite or silica, about 4 microns or smaller. And that what's in those voids, you know, tells you how that soil is going to move or not move and the rate that it's going to move. You know, if it's got a high amount of organic matter holding it together, then it's got that plasticity and stickiness that we know that becomes clay. If it's granular, you know, big grains like sand, it doesn't have that. Therefore, it's not going to have that structural strength to hold anything. And it fills in. All right. I'll go back to that later here. But anyway, as you can look, you know, all these pictures, by the way, that are in here, with few exceptions, are all out of compliance. It's done to, you know, get your mind thinking. When you look at OSHA standards, and as we go farther in this presentation, and I start with this picture, for the simple reason that it's really pretty simple. At 4 feet, you need a means of egress, no matter what the hole is. All right. If it's 4 feet or deep, there's got to be a way to get out. At 5 feet, you need a means of a protective system. Where do these numbers come from? Besides a lot of research, you can kind of go back to World War I. Anybody who's been in the military has probably dug a foxhole. All of a sudden, these two numbers I just flipped out to you make sense. You know, you hit that 4 feet, and pretty much at 4 feet for the average human, you have lung capacity in your heart. All right. You're not getting caved in. At 5 feet, you got a problem. Those are being suffocated. And then you look at this picture, it's great. You know, obviously this trench is deeper than 6 feet. All right. I always call this my favorite engineered protective system, sarcasm duly noted. But what happens when a trench caves in, and in my experience, I've had to do a few of these, not a lot. I did 1 death fatality related to a trench cave-in, and I did 2 accident, you know, cave-ins, and they're really pretty horrific. And it's not what most people expect. When that trench caves in, right, and on average, without going through the soil mechanics, and some of you already know this, a cubic yard of soil on average weighs about 2,700 to 3,300 pounds. All right. When it starts to move, it can move at speeds of upwards to 35 miles an hour. All right, guys, that's like getting, and gals, that's like getting hit by a truck. All right. So when these things cave in on somebody over their head, it's not that they're sucking down dirt, it's crushing them. When it buries them and there's part of their body out, the second accident I did related to a trench cave in, the individuals buried up to their hips. It still took the response team, because they were about 8 or 10 miles away from the closest local fire department. It still took them almost 40 minutes to dig the person out. Now, what typically happens when somebody has a cave in, the first thing is the impact, like getting hit by the car, and then it's immediately followed by numbness. They can't tell you if they got a leg going to the right, leg going to the left, arm going to the right, arm going to the left. They have no idea. You can't just jump in with a backhoe and start digging them out, because you're liable to cut one of the appendages off. And then, of course, when you release the pressure, they bleed out, if you can get the pressure off. The first person buried up to their waist, what typically happened is they had issues. It took them about 6 months of recovery, and I think they lost part of their foot. The second person was buried up just right below their rib cage. All sorts of internal organ damage. They had all sorts of organs removed. As far as I know, they're still alive, and they spent almost a year in the hospital in St. Paul, in and out, in and out. This would fail, that would fail. For those of you old style, first aid providers, back in the day, they used to have a thing called a tourniquet. Well, that's what's happening. When soil starts to kill you, it's like an anaconda. So picture if you had it all the way up to your shoulders, you may be able to temporarily talk to the person. As you say something, you go to take in a breath, the pressure's already pushing on you so much you can't fully inhale to get enough oxygen. And as you continue to talk or try to breathe, you slowly suffocate. And that's what happens. It's horrific, terrible way to go. All right, difference between a trench and an excavation by, OSHA and ANSI. If you look on the left, that's a trench. And the reason it's a trench is the bottom base is no wider than 15 feet. On the right, you see an excavation. You'll notice it's just one side of a wall. All trenches have an excavated side, but not all excavations are trenches. Just trivia for those of you who like technical stuff. Again, that 100 to 140 pounds, per cubic foot, times it by 27, you start getting the other part of the math. And I do like this picture. That's about 16 feet deep, and you have to ask yourself, what is that individual doing with a shovel down there? Anyway, one of the requirements for any trench is competent person, and also the people on the site being able to recognize a hazard. So one of the things I'd ask you to look for whenever you see an excavation, even if it's got a trench box in there by a company that supposedly knows what they're doing, as you walk up to it, look for the fissure cracks. Soil mechanics and engineering wise, they typically occur from the point of the cut at about 0.5 to about 7.5 or 0.75 from that initial edge wall. And you'll start seeing fissure cracks start showing up. So if they've sloped it and they've used the gravitational mechanical advantage of sloping and or benching, theoretically, if they've done it right, you're going to see them way out. If they have a trench box, you're probably going to see them closer. But the minute you start seeing those cracks, those fissure cracks, it's a key indication that the soil's moving. Okay, gravity is in the winning side at this point. Now, on the other end, when you're looking at the hole itself, if you start seeing slumping of material from the excavation face, again, it's moving. That soil always has that concept. It wants to push down and in. It's going to fill the void up. If there's nothing there stopping it, it's going to try to fill the void up. When that material starts slumping off of the excavation face, it's another indication this stuff isn't stable. Bulging or heaving of material at the bottom. All right. If it's water, it's going to boil. The way to think of that is I've got a very dense material such as a clay on top of a sand. I put it in a trench box and all of a sudden it breaks through. Perhaps right underneath that trench box and that little layer of clay, there is sand. It's a less stable material. You've made a cut. The box is going to fall in and push stuff up. Again, it's going to try to find its way to neutralize and fill. Raveling, again, another issue. Trickling into the excavation of pebbles, it's just anything falling into the excavation. It typically goes in a little bit and then it tends to pick up speed. Again, Mother Nature, if you want to call it that, gravity is trying to equalize itself. All right. Things to be worried about, vibratory stress. Now, having said that, all of you, I believe, Josh, don't you guys do a lot of road work stuff?
Yep.
All right. So you think of the road work you guys doing. You're designing these systems, you etch the earth. You're going to sit there, you're going to put in a road bed, you're going to have people compact it. With all these big heavy machines, you're going to spend hours doing this. You're going to lay concrete on there, and then you're going to have to do it again, unfortunately, in about 10 years. All right. Earth is moving. Vibratory stress is breaking stuff. The same thing happens in a trench, but only faster. All right. Once you've dug that soil out as previously disturbed, now we all understand that it's taken Mother Nature tens of thousands of years to get that compressive strength into that soil. And we just dug it up. We added to the size of the voids. There's no way we have the mechanical advantage to do what's been happening at that, 64,000 miles an hour concept going on. We just can't do it as humans. Same thing happens here. When we start vibrating that soil, we start breaking the bonding between those small grains. And when we start breaking the bonding, we start changing, the structure of the soil itself. The other thing is water. Water destroys everything when it relates to soil. Hot, dry weather. We could have great clay in, the east side of the state. I mean, it's structurally great. And then all of a sudden you open it up and it's like, July, and it's in the high 80s, low 90s, and you can literally watch it dry out. And that same hole that you dug for, say, a Class A soil, as an example, we'll talk about that later, all of a sudden becomes a Class B because the soil conditions changed. It dried out. Or vice versa, you dug it out for X and the water starts seeping in on that side of the state. All of you that are on the western side of the state, you're lucky because if you do see clay, it's usually only in a vein and everything else is absolute garbage, soil-wise. So when you walk up there and you start talking to the person in charge, you always want to ask them, what kind of soil did they classify this as? That's always the first question. And I'll talk about that in a little greater detail coming up. I put this slide in here. It's obviously not in the US, it's in Thailand, simply because it gets people's attention. Here you got one side that's kind of got an angled dugout. The other side is a face wall. You got water in the bottom. You have ladders in the trench that don't come 3 feet above. So if an employee does have to rapidly egress, they're stuck. You have a weird looking scaffold system. All right. Somebody standing on a plank, and not counting the other concept of snakes. All right. In each one of these job sites, the person you really want to talk to who's actually doing the dig or responsible for the dig. Let me rephrase that differently. The person who's responsible is called a competent person. A competent person isn't necessarily the supervisor or the foreman. A competent person is someone who's trained and capable of identifying those existing hazards and predictable hazards which are unsanitary or dangerous to coworkers. That's the key. All right. And then not only can they identify the hazard, they have to do the soils analysis to tell how that soil is going to move. And then the very last item is most critical. They have the authority to correct it. That doesn't necessarily mean it's the foreman. It doesn't mean it's a person in the backhoe. Usually the person in the backhoe can sometimes be the worst because their field of vision is skewed. When they look down, they may see everybody, in their mind, they may think they're all even because their hard hats appear to be even with the top of the trench. Only for the person who's standing on the trench or in the trench, you realize they're 3 or 4 feet below. But it's a competent person can do those 3 things always. And so one of the questions I would recommend you guys would ask when you see an excavation or a trench being dug is, who's your competent person? Then what kind of soil did you classify this? And then what's your protective system? And I'll keep hammering these points as we go through. Also, the competent person is probably the one coordinating EMS. In most of your big projects, the general contractor is going to have a recommended program on how they want emergency stuff done. It may be going through them, but if it's a small project, it's going to be up to that competent person if it's just that crew. And again, as part of the competent person, in order to make the previous decisions, the competent person is constantly inspecting the excavation. Again, you're all familiar with 811, call before you dig. For those of you that ever want to go into the OSHA standard, it's in like the second paragraph. It requires all companies to call the utilities and pre-locate them. Well, that became quite burdensome for individual excavation companies, so most states adopted an 811 system. And as all of you are probably aware, although each state has an 811 system based on the state code, they may be doing different things. All right. Again, states can always add to a federal law, they just can't detract from it. And obviously, you know, this is what happens if you don't call 811 prior. Just as a side note, I know you guys are out on lots of projects and they cover a wide scope of things, but if you have a contractor that's constantly hitting utility lines, even if they've called 811, one of the questions you want to ask, and when I was with OSHA, we would get, you know, calls from all sorts of cities, 811s and other organizations, is how are they doing their up close discovery of those utility lines? And that's usually where the failure is. I mean, granted, there's always that occasional line that's not marked, but when they're constantly hitting, say, gas, water, sewer over and over again from marked lines, that means they're not using properly a non-destructive approach to find those utilities. And then the question you have to ask, if you know you're out there representing the state, at what point do you think this is happening so often that statistically speaking, we're reaching a point where somebody's liable to get injured or killed? And at that point, you probably want to run it up the pipeline up to the top and ask some questions. Now, the other thing you can run into, and I'm sure all of you have seen it, is surface encumbrances. They can range from rocks, trees, telephone poles are a big one. You know, whoever the excavation company is, they have to secure those to make sure they don't fall into the hole and crush their own employees. And particularly like if you're in a city, you know, or doing some road work through a city, they'll hit a certain area, maybe there'll be a telephone pole and they just won't secure it. All right. And that's a disaster waiting to happen because you've taken the structural base out of that, you know, say telephone pole without securing it, has a high probability that it's going to collapse the wall in. So again, going back to that competent person, before they begin, they got to do that soil classification. And we're not, you know, make this part of a soil mechanics class. I'm sure all of you are familiar with a lot of that. But they're going to be looking at it from the standpoint of what's my grain size? Okay, do I have cohesiveness? Do I have the same stuff at the top as I have on the bottom? Because if I don't, if I have layers, I just downgraded the soil. It could be perfect Red River clay, and then all of a sudden there's a vein of sand. Whoops, that's no longer a type A soil. It's structurally compromised. If it's previously disturbed, in other words, somebody dug it up 30, 40, 50 years ago, it's compromised. That competent person is supposed to know all this. One of the other questions you can ask that competent person is, tell me how you did your soil testing. They should be able to answer it because they have to demonstrate it for OSHA. All right. You know, they could use, and we'll talk about different, you know, mechanical methods. They can use a Torvane shear, pocket pentrometer. Most of them are going to do a manual test. All right. They're going to roll that soil into a ball. They're going to see if they've got enough clay to roll it into a ball. They'll probably then go to a thumb penetration. Then they'll go into a ribbon test. And at the very end, they're going to do a plasticity test. That's going to tell them pretty much everything they need to know about whether that soil is a type A, a type B, or a type C. And the way OSHA looks at it, and the way that the company should look at it, is a type A soil is really dense clay. It's going to be able to withstand 1.5 tons per square foot of vertical pressure before this, you know, just picture a cubic foot of clay cut out. You can put about 1.5 tons before the sidewalls blow out. Or they're going to classify it as a type B soil, which is going to put it between 0.5 ton and 1.5 tons. By the way, that's the largest range. That is the typical soil that and C throughout the state of North Dakota. Just an FYI. And that's a huge range when you think about it. That's 2,000 pounds between 1.5 and half a ton. And then and that means same thing. You can make it into a square foot and it'll withstand that pressure before the sidewalls blow out. Now, if you go back to a type C, that's got heavy grains in it. And you're back to that scenario where it's less than a half a ton, per square foot that it's going to be able to withstand. And that stuff's pretty much not going to stand on its own. It's going to collapse under its own weight immediately. But again, that employee is going to look at it and they have to be able to demonstrate and define this is a type of soil that we're using. The other reason they do that is not just for the digging to cut it out, but to make sure that if they have a protective system, that protective system is actually rated for the type of soil it's being used in. All trench boxes, which we'll talk about also, and all shoring systems have to have an engineer's rating on what they can withstand. And then the employer has to make sure that they've read that tabulated data. They're using the box the way it was designed. All right. All this is, if you're in the OSHA standards, in Appendix A. Again, pocket pentometers. My personal thing is, yeah, they're a technique. I just don't like them because of that 20 to 40% margin of error. If you've never, I think, Josh, do most of these guys know what a pocket pentometer is?
That I'm not sure.
Okay, the basic concept is it's like a tire pressure gauge in reverse. You shear off the front of a big dirt clod, you stick the thing in there, and then it sticks out of the end out of the end, and then you release it, and it tells you what, as you can see, what your tons per square foot are. But it's got a 20 to 40% margin of error. The other one is a Torvane shear. It's very similar, except this one's spring-loaded. If you look on the top of that, you can see that there's, tonnage ratings on there. Again, I get a face of a nice dirt clod, I push it in and I twist. And at the point it breaks, then I've got my rating. Again, it's got that same margin of error. The more typical methods are manual because they're quicker, they're faster, and there's a series of them that you can do. And, I hate to date myself. It's probably politically incorrect, so I apologize ahead of time. But back in my day, in addition to snowball fights, you also got into dirt clod fights. And as a kid, even though you're best friends with your buddy down there, you guys would throw dirt clods at each other, and you'd want to find those that you could roll into a baseball or tennis ball size that would hold together so you could whip it, 20 or 30 feet. Guess what? It's the same concept for manual soils testing. Very first thing you want to do is, can I roll this thing into a ball? Does it stick? Does it hold? Kind of throw it in the air and catch it? Hey, that's got, now it's like that's got a lot of, clay in it. If I can't roll it into a ball, I already know it's type C soil. It's not going to stand. All right. It's going to slope like sand at a beach when you dig it. And then you'll see here, you do a thing called a thumb penetration test, and that describes it briefly. But the basic concept is, can you get your thumb in? If it goes all the way through and breaks, you're back to the C. If it goes into the end of the fingernail, you're probably in the B, but it still could be an A, et cetera, et cetera, et cetera. I'm not going to go into it in detail, but that's the basic concept of it. From this test, you would then break off a chunk of that same soil and you'd roll it into the size of a cigar. About 1.5 inches in diameter, about 8 or 9 inches long. And what you start doing is what's called a ribbon test. And you would pinch it between your thumb and your forefinger and let it curl down. And if you can curl it all the way down to your, little finger, all right, that tells you that the adhesion and cohesion of the soil is structurally enough that it's probably a type A soil. All right, and that's called a ribbon test. And at the end of that, you would break part of the ribbon off. You'd roll it into what's called a plasticity test, which is about the diameter of a pencil or less and at least 2 inches long, and that tells you it's a type A. These are really quick when you know how to do them. It takes about 2 minutes. All right, and a good competent person should know this and be able to demonstrate it, whether it's this or one of the other two methods. Another more scientific method that takes a long time is a dry strength test. But again, now I'm going to take soil and I'm going to dry it. In most of the projects in the Dakotas, we don't have time to sit around for several weeks and wait for this to happen. So I'm just going to skip it and go to the next one. Okay, I mentioned that plasticity or thread test, sometimes called a pencil test. And again, you take that last end of the ribbon test, and you're rolling that thing between your palms, and you're trying to get it down to a, 1/8 of an inch. Pencil diameter is smaller and 2 inches long. And that's telling you if it'll hold. Now, the other thing you have to do in the competent person, in addition to at least one manual, they have to have a visual test. All right, they're looking at that entire excavation. They're saying, okay, what do I have? They're looking at it as it's being dug. For those of you who've been around and seen enough backhoe work, you can kind of tell when you just look at the bucket come out. If the bucket comes out, has to do a little shake to get it out, you have a lot of clay in it. And then you'll also see it's kind of stuck to the outside of the bucket. If the bucket starts to move and everything just comes out, it's obviously very sandy. You can already tell just from the bucket. But then even with that being dug out, the competent person still has to do that visual trench when it's fully dug of the trench wall. Is the stuff at the top, soil composition-wise, the stuff at the bottom? If it's layered, it changed. And that means it's immediately downgraded. Again, and the different soil types as we've discussed, type A, really dense, heavy clay. If you think of modeling clay, that's that stuff. You'll find it on the west side of the state in veins everywhere. On the east side of the state, you find it a lot, but it's always compromised by water typically. Your type B soil, it's got a lot of clay in it, but there's a little bit of silt and there may be some sandy loam. And then of course your type C, I just say, think of the beach. When you dump it out, it just naturally goes to that gravitational hill. It just isn't going to hold. It's all in Appendix A of the standard. All right, you've got 3 different types of protective measures available to the employer, and that competent person's got to decide what they're going to do. We're going to talk here about sloping and benching, and sloping and benching is taking Earth's gravitational advantage and turning it into a mechanical advantage for the dig. That is all you're doing. Okay, it's that realization that, all right, based on how things push down and push in, if I cut a hole with this at the bottom and I slope it at X based on my soils analysis, it should stay long enough stable for my employees to go down there and not get caved in. So if it's a really good clay, all right, it's 3/4 to 1. And that's 3 feet horizontal to 4 feet vertical. That's because clay will hold, right? If it's a type B, it's 1 to 1. Okay, that type B soil, that half a ton per square foot to 1.5 tons per square foot. Yeah, I can mold it, but it's just not quite as strong as a type A. So that one, I got to change my angle of repose when I lay it down. I got to make it a little wider. So I'm going to go 1 to 1. And then, of course, when you get to type C, my reference is a beach. That's the best way to do it. You dig in a beach, it slopes to itself, and it always wants to go down to that 1.5 to 1, laying that angle even farther to keep it from rolling in. So here, and this is all in the Appendix B of the standard. But when you look at it, here's some pictures of what it may look like. And one of the hardest things you're going to find out when you talk to a really good, competent person, and they look at that 3/4 to 1 or 53 degrees, is that realization that, you know what? You really can't slope this stuff because it's so dense. I mean, the contractor can be out there, but it's going to take them a long, long time to get it sloped right. What they're going to do is they're going to bench it because that's less digging and still will give them that same angle of repose for the laying down of the wall on that, trench. And so here's an example of a benching system for a type A soil. If you notice on the bottom, you got that 4 feet in height. And part of the reason for that 4 feet of height for that first bench is you don't want to go up to 5 feet, because then all of a sudden you might have a protective system and a protective system. Now, I bring this up because some of you PEs that may have designed this stuff in the past for depths of 20 feet, OSHA's got a requirement that at 20 feet, it requires an RPE stamp for depth. Somebody's got to make sure it's engineered properly to withstand all the forces. It's not uncommon for a situation that's greater than 20 feet where an RPE would turn around and say, you know what? I want to put in a trench box down and take that 20 feet up to about 18, and then I want to bench out or some combination. But if you get deeper on that first bench than 5 feet, you start having to have a protective system and a protective system. That's the whole gist of what I was just trying to say. But so you see it goes up 4, over 4. You can see how that angle kind of starts moving up. And that's at 3/4 to 1. And again, you can bench it again and again and again, up 4, over 4, up 4, etc., etc. The other thing with a benching system, it allows a catch platform theoretically for the right type of soil on the bottom if something does break off before it hits the employee. All right, on type B soil, it's the 1-to-1, same concept, 1-to-1 rise to run. And over here, you'll notice something different. They come up 4 feet, but then they lay this thing out almost 8 feet, and that's to drop that angle. So your first bench is normally wider on type B soil than it is on type A soil. Again, they're just laying the angle of repose down. Now I put this picture in here because this is very deceiving. For those of you like weird stats, since the 30s, the average human in the world is considered to be 5 feet 9 inches and 74 kilograms, no, 70 kilograms, 154 pounds. I was that in 9th grade, I think, once for about a month and a half. So if you take a look at this, and by the way, you put a hard hat on somebody who's 5'9", guess what? You pick up an extra 3 inches. So typically you can, use that visualization. If the average person standing in a hole or standing up with a hard hat is at least 6 feet, assuming they're 5'9". So at first glance, when you look at this, you're thinking, wow, this doesn't look bad. It's benched. But if you look over to the top left, kind of under where the N is in the benching, you're going to see that that's the top of the excavation, almost in line with the top of his hard hat. So if you do a little extrapolated, what I call beer math, if you were to drive up and look at this, you'd go, all right, I've got 2 sides plus a bottom in any trench that always have to be cut. So I've got a 6-foot person. I got a 6 foot on one side, 6 foot on the other, and probably 2 feet on the bottom. I've got about a 14-foot width at the top that needs to be open. And if I'm that person and I stand with my hands spread from left to right, I can almost touch one wall to the other. So this is one of those cuts that looks pretty, but isn't done right. This is just FYI why the picture's in there. For those of you familiar with trenching, you picked up on it. For those of you that aren't, that's why it's in there, just kind of get the juices flowing. There'll be a couple more like that as we go through. Your type C soil, you can slope it. Remember the beach concept. It slopes really easily. All right. It's at 34 degrees because you're really laying this bad boy down to keep it from, falling in on itself. But you can't bench it because there's no structural integrity in that soil. It's not going to hold itself up. A type B soil's got that tons per square foot that'll hold itself up, and a type A will, but a type C soil won't. And that's really critical because depending on the protective system they use, it may or may not fit their needs. You can theoretically do stuff where it's one over the other. In this particular demonstration, you see a C over an A. Most of your companies won't do that if, for time. They will take the worst case scenario if they know what they're doing and they'll dig it to that. But it does allow that in the standard if you do run into it. I mentioned briefly protective systems, and I want to cover it real quick. There are 3 types of protective systems. We talked about the gravitational protective system, and that was the one with the sloping and the benching. The second one you can run into is shielding. And like I would recommend, think of shielding like you would see a knight in the Middle Ages. They have a shield. The shield is designed to take a hit. Whether it's from a sword or whether it's from arrows, it's going to take a hit. So a trench box or a trench shield is designed to take a limited hit. The other one you'll run into is shoring. Again, go back to the Middle Ages. You got knights on one side of the battering ram trying to take a door in. On the other side, the group is trying to shore that door up from being taken down or knocked out. Shoring system just applies pressure to existing structural walls. Shoring systems typically can't be used in type C soil because, again, it's not going to stand on its own. And so when you see a shoring system, hydraulic, pneumatic, whatever the shoring system or mechanical shoring system is that's being used, the question that's got to be asked is it being used properly for the soil that it's in? And again, that'll all be spec'd out in the engineer's tabulated data that comes with the system. So here's an example of a spoil pile. The reason they have a spoil pile and what the recommendation is 2 feet or more is because 2 feet puts vertical pressure on those ends, which may change the dimensions of that trench. So it's always 2 feet or more to take the spoil that's dug out and moved away. A competent person is required to do that evaluation based on the soil mechanics. They're saying, do I want it more than 2 feet? Do I want it less than 2 feet? Sorry, you can't have it less. It's always more. It's 2 feet or more. So when they dig the spoil out, you'll see some contractors, and you can kind of tell if they really get it. They'll move it more than 2 feet. They'll move it 4 or 6. Some of them will just haul it away if they're in a really tight scenario, because they don't want to deal with the actual additional weight that's going to be applied to those sidewalls, because it can change everything. Again, we're going to talk about adequately designed protective systems. So again, this one you can see, obviously, totally inadequate. There's look at the spoil pile. If you notice the spoil pile on the left, it's all the way to the edge of the trench. You've basically taken that sidewall and extended it however many more feet beyond the cut. So if that individual is approximately 6 feet, it looks like there's 2 or 3 feet to the cut above them, and then another 2 or 3 feet with the spoil above it. And all of it's putting pressure on that vertical sidewall, and that's a problem. As we talked about earlier here, shield, shoring, and sloping. Shield, think of trench boxes, takes a hit. Shoring holds everything up that's already there. Sloping is using, the gravitational mechanical advantages of the earth, sloping and benching. All the factors involved with these protective systems, other than sloping and benching, are going to come from the engineer. When the engineer designs a protective system, and here you see a trench box system, they're looking at it from the standpoint of the materials they put into the trench box itself, or the shield. All right, is it aluminum sided? Is it steel sided? What's their structural members? What kind of soils are they designing it for? How deep are they designing it for so it can take a hit? All that goes into the design before the RPE puts their stamp on it. It's incumbent upon the employer that's using the system to use it in accordance with that engineer's tabulated data. The requirement for any construction company, earth moving company, or whoever that's using a trench shield or a shore, they have that tabulated data with them on site so they can refer to it. So that's another question. So question number 1, who's a competent person? Question number 2, what kind of soil? Question number 3, what's your protective system? Question number 4, if it's a shield or a shore, can I see your tabulated data? And that kind of helps tell you if the person's a competent person. You'll run into some companies that I work with that do excavations, and you'll literally have foremen in the same company that like a certain type of trench box because they know that tabulated data inside and out. And they'll argue about who's going to get a specific box for a specific job on the day. That's one of those things that tells you, okay, I'm probably dealing with some pretty competent people because they only want a certain system a certain way. They've read it. And you can go through and you can ask them and they can tell you. And some of these tabulated data sheets, I've seen them as short as 2 pages. I've seen them as long as 20. It all depends on what the engineers put in there for the use of that system. And sometimes there's some pretty unique things. Shoring, again, supports what's already there. OSHA's got some generic shoring tables if the company wants to try to do their own stuff. Typically, these are all engineered, designed. And here's an example of aluminum hydraulic shoring. You'll notice there's panel, and these are vertical shores, by the way. those particular panels, you'll see on the side it says plywood. This is not OSB that you bought over at Lowe's or Menards. This is typically, inch and a half. It's usually birch. It's got multiple layers, depending on how the engineer wants you to use it. And the stuff costs buku dollars, like hundreds and hundreds of dollars a sheet. If you use plywood, a lot of the other companies now, they will have a prefabricated panel that they want you to use, or they'll have steel plates and they'll tell you X gauge steel at such a thickness. Again, the tabulated data is there. If the company's doing it right, they should be able to explain it to you. You will also see some of these systems that may not require paneling. It'll change the spacing, but will have a series of requirements from the engineer that designed the shoring system to say, here's the spacing requirements for it, and here's the soil requirements for it. Again, back to the competency of the competent person. Here's an example of a nice series of trench boxes, all right, stacked on each other, but there's some flaws with it. You see the guy on the left, he can fall in between the gap. And one of the other things to remember, whenever you see a trench, there's always 6 sides. Yeah, 6 sides. There's a bottom and a top and 2 ends and 2 sides. All those have to have a means and method of protection if an employee is exposed to a cave-in hazard. So the guy on the left up there, if you look at that back wall, it goes above his head still. All right, he's got an overhead hazard. That crew down there has an overhead hazard potentially that can go in. If you look at the crew on the bottom, we talked about that means of egress at 4 feet. If you look way back up here, I don't know if you can see my mouse, but if you look under the H and the L, you'll see a ladder. That egress has to be unobstructed. So you've got at least one employee who has to jump over a pipe and another employee who has to jump off the pipe. Unobstructed means of egress. Here's a horizontal whaler system. It's another shoring system, but instead of it being vertical, it goes horizontal. Same concept. What's the engineer's specs? Example of a horizontal whaler system, only with company manufactured plating. And you can see the hooks make it real easy for a backhoe or for the employees, depending on the weight or the material, to lower it in the hole themselves. Here, this is an example, a fire department practicing installation of a shoring system. Shoring systems normally get installed from the top down and removed from the bottom up. But this picture also shows some serious questions. Here's the guy in there putting it from the top down, and he's only got 2 walls. There's another 2 walls that aren't protected. One of them that could come in on him, and that's the one where the 2 people are standing. The other thing is, these are straight up and down cuts where the shoring system goes in, and before this thing is installed, look at all the weight from all the people standing on the vertical edge. That's a concern. Timber shoring. A company could use timber shoring. The specs are on the back of the OSHA standard. They're also on the ANSI standard. It takes a long time to install these, and it's really costly wood to use, but it is allowed. In this particular picture, you'll notice that the shoring system that's being used, it's not level, therefore its pressures are off. It's not uniform, another key indication it's not right. You'll see on the top right what looks like a tree. So you have a surface encumbrance that's not supported, and a spoil pile on the right all the way up to the edge. Here's a shielding system. Typical trench box installed. But when you have a trench box in, OSHA says, vertical trench walls projected at least 18 inches above. But again, it's going to go back to the engineer's design. Some of these trench boxes, the engineer, if they're really tall, will say, I want 2 feet of exposure. So when you look at this, in addition to the fact that the ladder is not right, because once you get out of the thing, you got to run across the ladder in a horizontal, that one wall on the right as you're looking at this picture goes above the trench box. So then you have an above box cave-in potential still there. Some of the boxes are designed to be stacked, and you have to read the tabulated data because some of the engineers in their designs will say, no, only use my boxes with my boxes. Or they'll say, only use my boxes that I've designed with these other companies. or only use them if the ANSI configuration is X to lock them. So just because, there's a series of trench boxes, that you have to make sure that they're allowed to be stacked. And then if they're allowed to be stacked, it changes the depth and the weight rating. In other words, if you got a trench box on the bottom that's rated at, say, to a depth of 14 feet, you're going to 18 feet, and the box on the top is rated at 14 feet. Just because there's two of them stacked, they can't withstand the load or the impact at 18 feet. They're, tapped out at 14. All that goes into the competent person should take that all into account when they design how they're going to use their protective systems. Again, another example of a trench box. One of the other things that's obvious is you can't take the vertical horizontal lift, aka the bucket, to ride into the hole. Classic example. There's no means of egress other than using the bucket. The other thing to also consider is if you look at the sides of these trench boxes, again, the engineer that designed the shield is going to tell you the gap width opening that you can have. Competent person should be able to articulate that to you. Some of them I've seen will say no more than 2 feet. Some of them will say, they want equilateral pressure applied. So dig it out, put it in, and fill it back in. There's any number of ways, and it all depends on the engineer and what they've spec'd out with the materials used in the construction of the box. But, so another thing to consider. This one, you see two trench boxes. They're stacked up. There's a question on the pinning and there's a question on the egress. That 18 inches from the top, this is an example of one with type C soil. And again, that 18 inches or more, again, some of the engineers I've seen in some of their stuff will say 2 feet, is because that's the catch. If that wall to the side is dug out right, or if some vibratory stress or something else causes a stressor on the wall all of a sudden shifts and moves in, it keeps it theoretically from going over the top of the box and crushing the people in it. Manhole shields. Whenever you get around manholes, there's a lot of ways to do it. This is one example. Some companies have developed actual manhole shields. Really cool systems, by the way. Four-foot rule, any means of escape. I brought that up right at the beginning, and that ladder's got to extend 3 feet above the top of the hole. So when you look at this one, yeah, it's pretty obvious. It doesn't extend above. They can't get out. They got to jump. You can also tell that the depth there's approximately 12 inches between each rung, 1, 2, 3, 4, 5, 6 to the top. So this hole's at least 6 feet with probably 2 or 3 more above, making it 8 or 9. When you do that visual look at the soil, there should be a couple of things that stand out to you. When you can see dig marks from the backhoe in the sidewall, it's an indication there's a lot of clay in it. It doesn't mean that it hasn't been previously disturbed. This has, you can see gravel in the bottom coming out, but it means that there's still a lot of clay in there. Again, one of those visual things that the competent person should be able to articulate. Again, daily inspections. In this particular case, you got a manhole and a hole. When it rains, you got a major problem here. The competent person is not supposed to allow people into a hazardous hole. This one is sadly funny. It's obviously, if you take that person back to that approximate 6-foot rule, the excavation's above his head, the spoil pile's moved back, but he's standing on a platform. There's another 2 or 3 feet. He's grabbing something that appears to be made out of metal. He doesn't have a hard hat for an overhead struck, and he's probably going to cut his hands apart grabbing that metal. A lot of your companies will have an excavation checklist. That's always a good sign if they've got one. It's not required. It's highly encouraged. So if they turn around and say, yeah, here's our daily checklist. By the way, it doesn't have to be pristine. Usually the companies that really use it will, mark and change things as they go along. It might be covered in coffee and mud. Absolutely great. That means they're using it. They're doing it. It's in one of those key indications when you're out looking at these sites. They have a pretty good idea of what they're doing. The competent person also has to take into account those other hazards they can see in the excavation. Water accumulation. They've got to get the water out. it changes the toe of all their sidewalls. All right. It could be as simple as a little trash pump, or they may have to use sand points and completely dewater the entire excavation from top to bottom. If they're tapping into existing lines, maybe it's a gas line, maybe it's a sewer line, they have to take into account the potential for oxygen deficiency from oxygen displacement or toxic vapors. And that also changes, their egress potential, and it may also change their recovery. All things that, are required for the competent person to evaluate. So if you walk up there and the person says, yeah, great, it looks really good. Yeah, I made it type, B soil. I got a trench box in there. And then you look down there and it's got 6 inches of water in it. You need to ask, can I see the tabulated data for the trench box? Again, did the engineer allow that? One of the other things that you'll see in the OSHA standard allows, and the ANSI standard, is a trench box can be no more than 2 feet off of the bottom, depending on the soil type, and if the trench box manufacturer will allow that. But the minute water creeps in there, that's gone. My experience has shown me that most people who design trench boxes, when the minute the water starts hitting the toe, if they do allow the box in without the water removed, they want it flush on the ground. So those are some things, visually when you see, they're questions to ask. This is a fun picture, nice utility thing, all sorts of problems wrong. The utilities are unsupported. There's water, the walls are vertical. You can see the one on the left starting to cave in a circle around that manhole. There's no means of egress that's unobstructed for either one of the employees. The only question on this one is, when is it going to cave in? Here's another example. No means of egress. They got hit in a rainstorm. That soil probably had a lot of clay in it. And particularly for those of you on the east side of the state, you can have really dense clay that's really good and stable. And the minute you add too much water, it can turn into a slurry pit and you can slide on it. And that's what happened here. Again, testing the atmosphere is always a requirement when there's a potential for atmospheric hazards. Think natural gas, sewer lines in particular. There's also a requirement if they have a vertical excavation. All right, and I say vertical, let's say they put a trench box in there, and they stack 2 of them where they come out, you come up to the edge, do you have a fault protection hazard? Or if, let's say you have a vertical excavation, you haven't let anybody in it yet, but you're going to just keep it open for a while, you have to have some means and method to protect employees walking by or other ones from falling into the hole. Another thing they have to take into account, you guys are, do a lot of stuff with roadways. And I'm going to go off on a tangent, Josh, so just bear with me. You'll do the muck D thing, which you've got all your barriers out there. But if the excavation company is digging adjacent to a roadway, not only do they have to be cognizant of being struck by, so they have to wear reflective vests, which are classified as signs because they're not PPE, but they should have a barrier protection to keep vehicles from coming into the excavation. They can do it a lot of different ways. They can stack the spoil pile on that side, on the roadside. They can park heavy equipment on the roadside to keep people from coming in. They can use concrete jersey barriers, but it's expected that they, have talked with whoever the design people are. If they've got to dig and say, okay, this is how we're going to do it. We need some sort of barrier for our hole to keep, the young teenager who's texting or whatever from losing, track, hitting a cone and going into the hole. That tends to be nationwide a fairly substantial hazard. So they could be doing everything right. They don't have the barrier, and some inattentive high school, whatever, old person like me, I'm in my Social Security age, hits it and goes right into the hole. Again, emergency response. Not all places can do trench rescue. So one of the things that's recommended for all competent people, if you're like here in Fargo and Grand Forks, they know how to do it. But if you're in the rural areas, they don't. So does the competent person have an additional set of phone numbers to give the local responders on how to do trench rescue? The last thing you want to do is have a bunch of people from a local fire department with good intentions trying to do the right thing and no training jump into a trench and have it cave in on them trying to rescue the person. There's certain ways to do it, and there's certain fire departments that are trained. It's kind of like grain elevator fires, everybody. Sometimes for those local emergency responders, it's just having somebody that can tell them, don't do this and do this, and they can figure it out. A competent person theoretically should have that set of phone numbers. And that's kind of what I just talked about in this one. All right. All right, here's some quick pictures of what appears to be obvious stuff. So if you look at this excavation right here, all right, obviously it's not cut right. There's a ladder in it, but look at the pipe down there. It's releasing something. That should cause any digger, anybody who's digging, a concern. Next thing is, instead of you going down there, because you can see there's a shovel down there, somebody should have called and got the utility shut off. On this one, you can visually see that there's different layers. You can also see that it's probably sandy to some degree because it seems to be caving in. The depth on this was about 14 or 15 feet. You'll kind of notice there's marks. These are actually old OSHA investigative footage or pictures from around the state, different ones. That's why the dates are on the bottom. Here's an example. Okay, you can see a shovel down there. So you're at 4.5 or 5 feet with the shovel. This trench is about 7 feet deep. Spoil pile has been moved away a good 2 feet, and it's on the roadside side, so vehicles can't, drive in. But it's not sloped or benched for any employees, and there's plenty of footprints in the bottom. I don't even know what I need to say about this one, but if you kind of look down that excavation, you'll see where it's starting to cave in at different spots. You'll see the spoil piles right on the edge. So you can think of that compressive weight. The soil by itself, it's all granular, heavy granular. It's varying degrees of B and C, and it's just starting to cave in. This one, you see a utility line. If you look on the right, you see a ladder, but that employee has an obstructive way. He's got to jump over the pipe to the ladder. They're using a watering system. It's not sloped or benched properly if you look at it. And if you look, they're trying to hold the utility up, but instead of running that I-beam farther, they supported that heavy concrete utility line right on the edges of the excavation. All right, they didn't take into account, if I remember at the very beginning, I talked about the fissuring points, usually at 0.5 to 0.75 from the original vertical cut. They didn't take that into account. Therefore, they're putting all of their columnar stress right on the edge of this trench. Another example of what you might run into is in Bismarck. Again, you've got two different lines. He's worried about the electrical. I get it. On the backside, though, there's an insulated line with asbestos. Spoil pile is all the way up. Depth of the hole is at least 8 feet. Cave-in hazard. Please understand I'm old. I have a really cynical and sarcastic sense of humor, everybody. But some of these, when you look at this one, you got a barricade portion. Now, this whole trench has got utilities, you got electrical wires and water. You can't get to anything. You've got unsupported utilities, et cetera, et cetera. It's an absolute mess, and all of you can see it. But you got to ask yourself, really, everybody? I got a barricade. So with all these other utilities down here and all the potential for accidents, the individuals who dug this were most concerned about whatever that pipe is, that they disassembled the barricade on the top to hold that up. That should scare the bejesus out of you walking up to it. The other thing, if you look to the left of that barricade, you'll notice those vertical lines where it's starting to get ready to crack and shift and shear and cave in. This one, 10-foot high trench box. About 20 feet deep. If you look at the top left, you'll see power lines. Those are heavy power lines, buried heavy power lines. Nothing there for protection. That whole wall can go over the top. Should have had a PE involved with a professional engineer at 20 feet in depth. There should have been no question of the depth and the protective systems, because if you look right next to the individual, there's a grade mark. So you can do your elevation calculations right off of that, from where that water pipe is to where it needed to be. So here's a good example of one, sheet piling, quite commonly used. But if you read sheet piling instructions, whenever a company uses sheet piling, again, it requires an engineered spec system to make sure the sheet piling is correct. Because a competent person's not going to know the depth of the toe when you pound on the sheet piling. It's going to require an engineer to do that soils mechanics test to make sure it's correct. So whenever you see sheet piling, it's an engineered system. Where's the engineer's specs for it? Each one is custom. All right. And just a summary, cave-ins occur suddenly. Soils have varying, abilities. And kind of what you always want to ask if you're out there and you see this is who's the competent person? What's the soil? What's the protective system? And if they're using a shielding or a shoring system, do you have your tabulated data? Explain it to me. Josh, did I kind of cover it? This is a lot of information, guys. I took about a 2-day course and tried to cram it into an hour.
You did. It was very good.
Okay. Any questions, anybody? Josh, if there's no questions, I'm going to bail. Is that okay?
Perfect. I don't see any questions. I appreciate it. Thanks, John.
All right, guys. Good luck. Have a good summer. All right.
You.
Bye.
Well, thanks everyone. That wraps it up for this week. Next week we have starting out with Hall Hub on e-ticketing, and then Justin Ramsey giving a spec update, and then John Collado with design doing some supplemental design data. All right, we'll see you next week. Thanks.